So I'm Robin Meehan, I'm the CTO, Chief Technology Officer for Smart421. We're a systems integrator UK-wide. We're owned by the KCON Group, so we've got UK coverage. We're about 250 people, that sort of order, and we specialise in complex integration, typically delivery, service management, typically in tightly regulated markets, so complex markets, finance, insurance, telco, those kind of areas. So, first thing, just stepping back to cloud computing for a moment. This is relevant, it may not feel like it is, but it is. Now, the point I want to make about cloud computing, very similar on the kind of hype curve, is I've been saying for 2 to 3 years how disruptive cloud, and specifically I'm really focusing on infrastructure as a service and platform as a service rather than software as a service here. I've been saying how disruptive it is for 2 to 3 years. And I'm now going to completely contradict myself. Right? Because cloud, in my view, is actually sort of minorly disruptive, right? Which sounds like a kind of mad statement, but cloud computing is really disruptive to the market and to the incumbents in the market and the players and so on. But actually, so this is why I've chosen this image, is because a replacement bus has been arranged. Okay, so it's disruptive, but not in the way that big data, I think, can be or will be. So we should all be happy about that, right? I mean, generally, that's happy. That's a good story and much happiness. But my point is that big data is massively disruptive. So I've changed my mind. It's a great thing, I guess. I'm not a politician, so I can change my mind. So I've decided that big data is way more disruptive than cloud computing, and I thought that was off the chart. The reason I think it's so disruptive, or such a significant effect, is because the cost savings are not infrastructure costs cut by up to half, and maybe 6 months quicker to market, those kind of things, which are great, and businesses scream for those kind of things, right? It's more a case of if you can find the extra insight in the data that you already hold, or the extra data you can aggregate and gain business insights from, you can just trounce through competition. So the opportunity for disruption in markets is even greater. The telco space, classic problem in the UK telco market. Everybody's got a mobile phone, has already bought one. The market's pretty saturated, or completely saturated, and so you're just trying to steal customers from your rivals. You're not going to sell to anybody else in that market. So customer churn is key, absolutely key. Reducing customer churn. If you can understand your customers' behaviours and the trends better than your competition, and just reduce your churn rate by, say, 1%, the effect on the bottom line is just absolutely dramatic. So that those marginal insights, improved insights you can gain from understanding the data you hold or gaining extra data, don't just get you 50% better cost, they drive competitors potentially out of the market. So retail, not what Wolves is an example of big data, but in the retail sector, again, very low margin, and the whole kind of Tesco club card movement and those kind of things, all those precursors to what I guess we now call big data, are the key battleground in terms of differentiation in these markets, I feel. Organisations have been processing large data sets and performing analytics operations and getting insights and having data warehouses and doing business intelligence for a very long time. What's changed is the economics of that have now just been rewritten by the happy marriage of cloud computing and big data technologies that exist. So Hadoop, which is a key technology in this space, is not new, but marrying that with cloud computing and that elastic ability to have computing resource and then just shut it away and not have to pay for it. Basically, you don't need deep pockets anymore. And that's the transformational thing in my view. But the price performance point has just been rewritten. I don't think the technology is particularly new, even though it has massively advanced. It's the economics that's changed in my view. So, getting on to what this means in practice. Well, it's still really early days. So this is very much aimed at companies or organisations who are kind of getting started. This is your kind of day one where you might start the journey, I guess. So just to talk through how big data exploitation might actually work in practice, Hadoop's some open source software that's under the Apache license. Apache being the kind of key open source foundation, and Hadoop is the open source software product that is the kind of big daddy of the big data space, right? It's the kind of de facto thing that's really given it a kick and moved things forward in the last few years. Hadoop is, what it is fundamentally, is it's a batch processing framework that allows you to take some algorithm and massively scale it up across a number of machines. So typically, the way it would work is the first thing you go through is this kind of discovery phase where so our customers don't necessarily understand what insights there are in their data. They have a kind of idea. They feel like there's some magic in there that they're missing out on, but they don't really they're not close to it. They don't really understand it. So the first phase, as I said, is a discovery phase. You load your assets of data, which could be from multiple sources. So it could be from existing customer sources. That's the most valuable because you have it and your competitors don't. But also external data sources. So it could be weather or Twitter or lots of different potential data sources. Load that into your Hadoop cluster. So that's an extract, transform, and load problem, essentially. And then you go around a number of iterations. This is just ad hoc kind of, essentially it's like the, I think Brian Cox would probably describe it as a scientific method applied to data. So you have a hypothesis. I think that cars crash more on rainy days. Pretty stupid hypothesis, but let's just take that one. I think cars crash more on rainy days, so I'll take my accident claim data, I'll take my weather feed, and I'll run some analytics, just ad hoc, just sitting there running them, come back in half an hour, see what the data is telling me. The key person from a business insight point of view is the customer, is a term data scientist. So a customer data scientist is somebody who understands the data in their organisation, understands the business domain really well, whatever that domain is, and they're usually pretty, if you like, technical, kind of scientific in their outlook on life. Understand correlations and statistical analysis really strongly, but they're not necessarily developers or programmers, and some of them are, but quite often that's a different skill set to the person who can actually make it flesh, if you see what I mean. So in the insurance industry, which is where the case study is from, this is kind of the actuarial guys who are looking at risk analysis of who's most likely to crash their car against who isn't, etc. Once you then get to this green arrow, then you've learned something. You think, well, if I could run this analysis every night or every hour or once a month or whatever's appropriate, then I could gain business advantage from that, which could be reducing your costs. It could be increasing your market share, etc. Any of those things I've talked about. So this is just the productionization of that, of the algorithms you've refined in here. So then the key bit, the 100% crucial bit, is on the right-hand side. Is the business value, the business exploitation of that. So what that means is you might feed the results of that. So you might take this much data in, you might process it down to a list of all the customers and who's most likely to churn off your platform in the next week. You work out the top 1,000 customers who you think are going to churn off your platform based on how well they pay their bill, how many phone calls they're making, their age, their gender, right, let's say. And then you feed that into your CRM system, and you maybe just do this on a daily basis. You feed it onto your CRM system, and you do outbound, or into your outbound dialer, and you do outbound dialing to the top 1,000 customers every day to rescue them. And you rescue maybe 30% more customers, high-value customers, than your competitor does, and you just gradually win the war, right? So it's really significant if you can get those things working really well. So onto a case study. So this is from Aviva. Aviva's one of our big customers. Insurance sector is really nice because they have lots of data, right? So Quote Me Happy is a sub-brand of Aviva. So Aviva have a number of brands in the market. Now, if you're in the aggregator market, this price comparison market, then it's all about having you'll be surprised to hear, it's all about having your price come up at the top of the list, right? So the strategy is what you do is you sell the bare bones, ripped down product, barely insurance. That's unfair. And then you upsell all the add-ons, right? So once you've driven the customer to your site, you then try and upsell all the add-ons. I'm paraphrasing the industry a bit there. So, but the key thing that happens in that market, what you do is you get an absolute shed load number of quotes, but your conversions are incredibly low. So you might do 100 quotes, as people come through from the price comparison sites, and you might sell 1 in 100 or something. So your conversion ratios are tiny. But if you can trigger that conversion ratio up by 0.5%, you've added 50% to your entire insurance book. So the sensitivity is immense, if you see what I mean. So guess what? Classic big data problem. So what we did with Aviva, with Quote Me Happy part of Aviva, is we ran a project basically to take the fear out of big data. So what we did with Aviva, the first phase was run sessions and workshops and discussions with their actuarial staff to say, what are the questions, the business questions you want to ask of your data that you've never been able to ask? So we defined some candidate business questions, three of them, one of which I'll go through a bit more. And then we just tested. So we created the hypotheses, as I said, and then we tested those hypotheses against data, basically. And the objective of the exercise was to show what the price performance was of answering those analytics questions. So the point was not so much what's the answer to the question. The point was, if I have questions I want to ask of my business data like these, how much will it cost me to find out the answer? So when the next question comes up that they haven't thought of yet, because they know their business better than we know their business, that'll always be true. When the next question comes up, the barriers to big data exploitation have been removed because the fear's been removed. In a technology sense, we did this on Amazon Web Services, of course, so that's the thing that's got our skin in the game, because it's now feasible to run this on cloud platforms. So just a little bit of detail on that. So we used one of Amazon's services or products called Elastic MapReduce, which is EMR. Elastic MapReduce is essentially a hosted Hadoop implementation that I mentioned earlier. And so with Amazon, just going through these slides, essentially you can launch a new job, which is a processing job. What we're saying here is we're going to run two small virtual machines, computers. So small and 2, and you can say large and 100, right? So it's literally as simple as, do I want it that big, do I want it that big, etc. And I'll show you some stats on that later. And these are the price points. This may be a bit out of date, but it'll only have gone down, not up. So the price points for that was 15 cents an hour. So that's 30 cents an hour to run this two machine Hadoop cluster. The way Amazon price it is actually they charge a premium on top of their core cloud offering. So their cloud offering for a small machine is 9 cents an hour, an outrageous 9 cents an hour. And so they charge 6 cents an hour extra on top because they're running Hadoop and managing it all for you. Okay? And then so some code. Right? I'm not going to go through the code. So we defined a number of business questions. So the business question I'm just going through here. So one of Aviva's challenges is when they set up these separate sub-brands, they're at risk of cannibalising their own revenues from their main brand. So if you set up a different brand, you might actually just be competing and stealing your own customers and making no more money. In fact, spending a lot of money to make no money. Anyway, one of the standard languages is Pig, that's what Pig looks like. It's pretty obvious, and it's just sequential. Do this, then do this, then do this, and you just create result sets and you refine them over time. I wasn't intending to go through it, but just give you an idea of what it looks like. So I mentioned on the previous slide about the most important bit is the business value at the end. So I just wanted to show, this is just some visualization we did for this project. This is using Pentaho. Key point is that without the visualization in the appropriate format of the results of whatever you're doing, then that's utterly crucial. Right, so then on to the conclusions, as in from this exercise, the costs, I think are really interesting. So if we're just focusing on the top bit first, the key thing to get across is the cost of that. So if I ran that query every night and then just shut the cluster down again, then it's ranging from 72p to £2.34 to join 5 million to 5 million queries across 2 channels, right? Quotes, sorry. Now, I think clearly you've got to take the business context into account there, because you don't really know how complex that really is to do or isn't to do. But my point is that it's not £100,000, it's not £2 million, and if I make a bet and I get it wrong, I've lost in the order of less than £1,000 probably. So the opportunity cost is so heavily wasted in favour of experimentation and exploitation compared with the previous model. The challenges I see is I think the primary one is organisations just really struggle to get their head around what the new art of the possible is. So it's thinking about how I could get market advantage or drive my costs down or whatever it might be from data insights. That's a real challenging thing. That's challenge number one. Another challenge is the market is hot as you like. So as I said, data scientist is a good thing to have on your CV. Hadoop's a good thing to have on your CV. And so there's an impending skills shortage, which I think will get really much worse in the next year as the economy's picking up. That's definitely a challenge. Data quality is a challenge, but access to data as well is also, as I mentioned before, quite a challenging thing. So I think data security is obviously another key one. So it's closely related to the whole, for me, to the whole data security issues around cloud. So my position on that is it's all technically doable, but there's still a huge confidence issue to overcome, of course, not massively helped by the whole Prism experience. So what are the trends? I think we'll probably touch on this in the panel session, I suspect. But, oh man, there's so many technologies out there, it's absolutely frightening. The rate of change and innovation is incredible. So I think, so Hadoop is kind of, though it's the daddy in this area at the moment, Hadoop is almost becoming a foundation for other technologies. So Hadoop is fading in prominence in some ways. That's kind of a mad thing to say because it's really dominant. But Hadoop is fundamentally batch-oriented, as in you run something and some minutes later, 2 minutes, 10 minutes, 3 hours, you get your response. But you can run across 1,000 machines to get it. But it's not real time. The key point is it's not a real-time technology. So the big initiatives in the big data space, technology-wise, are all about driving real-time, doing more real-time analytics. So it's I guess the thing to say on that is it's an incredibly exciting time for, from a technology point of view, and this is really nerdy, I know, but from a technology point of view, and so I think one of the challenges with implementations is whatever you do now will not be current. In 2 years' time, it'll look quite, you'll have to, it's a journey, it's an evolution. That's the reality of it. But it's about survival of the best informed, is the way I see it, is that the differentiator in the business sectors is going to be around who understands their customer and their market and behaviour patterns best. Those are the ones, it's not the ones who have squeezed 30% out of their infrastructure. That's something you should have been doing 2 years ago on cloud, if you like. It's the ones who have understood their customer behaviours the best and the best informed. Those are the guys who are going to still be here in 5 years.